Hello everyone, this is our second lecture of Unit 2 Complex Integration in the course 19MA 204 Complex Variables and Ordinary Differential Equations. So in this lecture we are going to discuss about Taylor series and Laurent series. At first I am going to explain what is Taylor series. F of z is analytic at all points inside with the center at the point z equal to a. Then f of z equal to f of a plus z minus a by 1 factorial f dash of a plus z minus 2 the whole square by 2 factorial f double dash of a plus etc. This is our Taylor series expansion of f of z at the inside point z equal to a. So let us have the first problem under this category. Expand 1 by z minus 2 at z equal to 1 in a Taylor's theorem. So in the first column I am taking the function. Second column, at the given point we have to find out the corresponding function value. So first given f of z which is equal to 1 by z minus 2. Parallelly I am substituting the point z equal to 1. I will get f of 1 value is equal to minus 1. Next I am finding the first derivative with respect to z in f of z. So 1 by z minus 2 value is minus 1 by z minus 2 the whole square. When I am replacing z equal to 1 here, I will get minus 1. And f double dash of z value. So while I am differentiating 1 by z minus 2 the whole square, I will get minus 2 by z minus 2 the whole cube. Minus 1 into minus 2 become 2. So now I am replacing z, that means z equal to a. A is 1. So therefore f double dash of 1 value is 2. It will go and so on. Now I am going to replace this in f Taylor series expansion formula. We have the general formula here. At the given point z equal to 1, here a is equal to 1. While I am replacing a is equal to 1 in the previous general one, I will get f of z expansion is f of 1 plus z minus 1 by 1 factorial f dash of 1 plus z minus 1 the whole square by 2 factorial f double dash of 1 plus etc. Now I am replacing f of 1 f dash of 1 f double dash of 1 value from the above previous table values. I'm having f of 1 f dash of 1 and f double dash of 1 values. Substitute that value here. F of 1 is minus 1, f dash of 1 is minus 1 and f double dash of 1 is 2. This is our final Taylor series expansion of f of z at the given point z equal to 1. Now we have the another problem. F of z equal to z by z plus 1 into z plus 2 as a Taylor series about the point z equal to 0 and z equal to 2. They are given 2 points. We have to find out each point value separately. Before that, look at the denominator. We are having more than one factor. We cannot able to differentiate this function directly. So therefore, we need to make it the denominator term into single factor. For that, I am using partial fraction. So while I am using partial fraction for the given f of z, can I write this into a by z plus 1 plus b by z plus 2 because there is no square in the denominator. After that, I am taking LCM. So after taking LCM, the both the left hand side and right hand side denominator getting cancelled. The remaining things are z equal to a into z plus 2 plus b into z plus 1. For finding a and b value, we need to substitute some substitution value for z. For finding b value, I am using z equal to minus 2. Then only the first term becomes 0. I will get b value is equal to 2. When I am replacing z equal to minus 1, then only I can able to eliminate b term. I will get a value is equal to minus 1. I am using these two constant value into equation number 1. That become f of z equal to z by z plus 1 into z plus 2 become minus 1 by z plus 1 plus 2 by z plus 2 because a is equal to minus 1 and b is equal to 2. F of z become like minus 1 by z plus 1 plus 2 by z plus 2. Now we can able to differentiate this function. So look at the table. First I am taking the function. Second column I am taking the values at z equal to 0. The third column gives values at z equal to 2. First I am having f of z is minus 1 by z plus 1 plus 2 by z plus 2. I am replacing z equal to 0. In f of z I will get value is 0 and when I am replacing z equal to 2 I will get final answer 1 by 6. Like away I am finding f dash of z from this f of z. While I am differentiating 1 by z plus 1 I will get minus 1 by z plus 1 the whole square. Minus into minus become positive. So 1 by z plus 2 value is minus 1 by z plus 2 the whole square. So minus 2 by z plus 2 the whole square. So when I am replacing z equal to 0 in f dash of z, this value become 1 by 2, and at the point z equal to 2, f dash of z value is 5 by 24. I am just replace z equal to 2. I will get, after simplifying, I will get 5 by 24. Like away, I'm finding the second derivative value f double dash of z. From this f dash of z with respect to z, I am differentiating. So 1 by z plus 1 the whole square. This differentiation value is minus 2 by z plus 1 the whole cube. And 1 by z plus 2 the whole square differentiation value is minus 2 by z plus 2 the whole cube. Minus 2 into minus 2 become plus 4. So therefore, I am substituting z equal to 0 and z equal to 2. That gives the value, so minus 3 by 2 and minus 5 by 432. So I am going to use these values into the Taylor series expansion formula. This is our general formula. So at the first point z equal to 0, we have the above general formula is f of z equal to f of 0 plus z minus 0 by 1 factorial f dash of 0 plus etc. In case of here, I am replacing 0. I am having f of 0, f dash of 0, f double dash of 0 values in the table, replacing all those things and simplify. Finally, f of z value at the point z equal to 0 is z by 2 minus 3z square by 4. So let us have the second point z equal to 2. In this point, we have f of z is f of 2 plus z minus 2 by 1 factorial f dash of 2 plus z minus 2 the whole square by 2 factorial f double dash of 2. In general formula, I am replacing a is equal to 2. I will get this form. And finally, I am replacing the function values f of 2, f dash of 2, f double dash of 2. I took these values from the table. At final f of z value at the point z equal to 2 is 1 by 16 plus 5 by 24 into z minus 2 minus 5 by 432 into z minus 2 the whole square by 2 factorial. This is our final answer for the second point. Let us move on to the next problem. Suppose in some of the cases they won't give any other point, they may give the region for the given function. Means in this particular problem we need to follow some other method. Here also we are having more than one factor. I am using partial fraction. So look at the numerator order and denominator degree. So here degree is order of z, not degree. Order of z equal to 2. Here also order of z equal to 2. 1. Here z also 1. So 1 z into z square. Suppose numerator order and denominator order must be equal, or numerator order is greater than the denominator order. Means suppose we are having z cube, in the denominator I am having only z square. In this case also we need to use this formula, 1 plus a by z minus 1 plus b by z minus b. I am going to use this formula. This term become 1 plus a by z plus 2 plus b by z plus 3. Okay, after taking LCM, the denominator getting cancelled, the remaining terms are z square minus 1 is equal to z plus 2 into z plus 3 plus a into z plus 3 plus b into z plus 2. I am replacing z equal to minus 2, I will get a is equal to 3. When I am replacing z equal to minus 3, I will get b is equal to minus 8. I am using these constant values into equation number 1. Equation 1 become f of z equal to 1 plus a by a is equal to 3. 3 by z plus 2. B by b is equal to minus 8. Minus 8 by z plus 3. So therefore, f of z equal to this particular thing. Take this as equation number 2. Now consider the given region. Given region is modulus of z less than 2. Whatever they may give, you make it that into less than 1 form. That means suppose some of the cases 2 is less than z. 2 is less than z means we need to move that z into left hand side. Whatever we are having in the greater side, that will go into left hand side. Then only I will get less than 1 value. So therefore I am just moving this constant into left hand side. Z by 2 is less than 1. Of course, look at the denominator. So inside the circle, inside the given region only, we need to find the Taylor series expansion. Z by 2 is less than 1 means obviously Z by 3 is also 1. When I am dividing Z by 2 means we will get less than 1 value means obviously while I am dividing Z by 3 also gives less than 1 value. So therefore in the first time I am taking 2 outside because in this particular given region become Z by 2 form. So Z by 2 is less than 1, that's why making the denominator into Z by 2 term. Second term also Z by 2 is less than 1 means this is also less than 1. For that purpose I am taking in the second term 3 outside. In some of the terms we are taking Z also outside, for that I am telling you later. Now I am moving both the denominator into numerator. So this looks like the binomial expression formula 1 plus x power minus 1. This gives alternative sign 1 minus x plus x square minus etc. So in the first term I am having in place of x is equal to z by 2. In the second time I am having in the place of x is equal to z by 3. I am expanding this using this binomial expression. I will get f of z equal to in this structure. So this is our final value for the given problem f of z under the region modulus of z is less than 2. So let us move on to the Laurent series. Let C1 and C2 be two concentric circles and R1 R2 are the radius of this particular circles where R2 is less than R1. Let f of z is analytic on C1 and C2 and in the annular region or between them. Then f of z equal to summation n varies from 0 to infinity an into z minus a whole power n plus summation n varies from 1 to infinity, here varies from 0 to infinity, here varies from 1 to infinity, bn z minus a whole power minus 1, here positive power, here negative power, where an is equal to 1 by 2 pi I integral over the first circle f of z by z minus a whole power n plus 1 into dz, and bn is equal to 1 by 2 pi I integral over the second circle f of z by z minus a whole power 1 minus n into dz. Let us have the first problem. In the region they are given two region, not one, two region for the same function f of z. I am going to find out one by one for this function. So in this given function also we may have more than one factors. So therefore I am using the partial fraction. Compare the numerator and denominator order, both are same. That's why I am using the above formula. After expanding this by partial fraction and take the LCM in the RHS side and cancel out the denominators both the sides and substitute some values for z. I will get a and b values are 3 and minus 8. I'm using that values in equation number 1. I will get f of z equal to 1 plus 3 by z plus 2 minus 8 by z plus 3. These are the same function we are dealing in the previous problem also in under Taylor series. Now the region is modulus of z is less than 2. First region they are given modulus of z is less than 2. The second only will differ. So make it that into less than 1. Z by 2 is less than 1. Obviously z by 3 is also less than 1. That's why I am taking in the first term 2 outside, in the second term 3 outside. Next let us move this both denominator into numerator. This looks like the expression form 1 plus x power minus 1. I am using this formula. Expand 1 plus z by 2 minus 1 and 1 plus z by 3 minus 1, we will get like this. Next I am developing the general form of this particular series. So that is a Laurent series expansion. So alternative sign is there, that's why I am using minus 1 power n, and for all the terms containing z by 2 except first. So therefore z by 2 power n, but the first term I am having 1, no, that's why n varies from 0 to infinity because this whole power n 0 is 1, that's why. Second term also we are having for all the terms z by 3, so z by 3 power minus 1, alternative sign is there, that's why I am using minus 1 power n. So this is the nth term of the previous series. Let us move the second region. Yeah, given the second region is 2 less than modulus of z minus 1 less than 3. So for this kind of cases, in place of z I'm having either z plus something or z minus something, means we need to use some substitution for this case. Z equal to u is equal to z minus 1, so therefore z equal to u plus 1, and in place of z I want to use u plus 1. Okay, which gives the above region become 2 less than modulus of u less than 3. So I'm for we may consider this into two cases. First case, I'm taking only 2 less than modulus of u. So this gives 2 by modulus of u less than 1, which means we want to make it this inequality into less than 1. That's why I'm moving this modulus of u into left hand side. This gives less than 1. Consider the second half. Modulus of u is less than 3. While I'm moving this 3 into left hand side, it gives less than 1 value. Okay. So f of u is, of course, f of u is equal to, because in f of z function I'm just replacing u, that's why that function become f of u 1 plus 3 by z plus 2 minus 8 by z plus 3, z is equal to u plus 1. I'm using that here. After that, after simplifying the denominator, it will become u plus 3, u plus 4. Look at the previous one. 2 by u is less than 1, u by 3 is less than 1. So 2 by u is less than 1 means, so 4 by u is also less than 1. In this step containing 3, no, so it is similar to this, so that's why I'm taking 3 outside. U by 3 is less than 1. We don't have this constant in the given inequality, that's why I'm compare this with 2 by u. So 2 by u less than 1 means obviously 4 by u less than 1, that's why I'm taking this u outside in this particular step. Okay, now I'm moving the denominators into numerator and expand this by binomial expression formula. I will get this structure. So I'm developing the nth term of the previous series. I will get f of u is equal to 1 plus summation 0 to infinity minus 1 power n u by 3 power n minus 8 by u. Summation varies from 0 to infinity minus 1 power n 4 by u power n. Now at finally we need to use u is equal to z minus 1. Initially we are taken u is equal to z minus 1, no, that's why I'm replacing in final answer u is equal to z minus 1. I will get the final answer f of z equal to in this way. Let us move on to the second category. Apply Laurent series for 1 by z into 1 minus z in the region 1 less than modulus of z plus 1 less than 2. Here also we are having more than one factor. Using partial fraction and taking LCM in the RHS side, both the denominator getting cancelled, I will get 1 is equal to a into 1 minus z plus b is z. Finding a and b, put z equal to 0, I will get a is equal to 1. Put z equal to 1 in this particular equation, I will get b is equal to 1. Replace a and b in equation number 1. Equation 1 become f of z equal to 1 by z plus 1 by 1 minus z. Given region is 1 less than modulus of z plus 1 less than 2. Use substitution for z plus 1. Take that into u. From this you have to find out z value also. Z equal to u minus 1. Okay. I'm using the substitution into the given region. The region become 1 less than modulus of u less than 2. I may consider two cases for this inequality. The first one is 1 less than modulus of u. The second one is modulus of u less than 1. Make it the both inequalities into less than 1 format. Here for making of less than 1, I just want to move this modulus of u into left hand side. I will get 1 by modulus of u is less than 1. But there is no 1. The yeah, of course 1 by u is less than 1 means 2 by u is also less than 1, and here we need to move this 2 into left hand side. It will become u by 2 is less than 1. Yeah, come to the equation number 2. In equation 2 I need to use z equal to u minus 1. That become 1 by u minus 1 plus 1 by u plus 2. So for using binomial expression formula, I'm just rewrite this u minus 1 into 1 minus u. I'm just taking 1 minus outside. Direct away I'm moving that into numerator because already this is in the form of 1 minus x. Okay, the second, I need to make this in by using the binomial expression form. For that, I need to take either u or 2 outside. Look at the previous step. 1 by u is less than 1 means 2 by u is also less than 1. For that, I am taking u outside in this particular step. So let us move this into numerator and use the binomial expression formula for both the terms. And this looks like negative and negative. For all the terms are positive. No need to use minus 1 power n here because all the terms are positive. So u power n, nth term. Here alternative sign, that's why I'm using minus 1 power n. In place of x, I'm having 2 by u. So therefore 2 by u power n. So both summation starts with 0 because both terms containing the first term value is 1. That's why. This is our nth term. At finally, we need to use u is equal to z plus 1 because we are taken z plus 1 is u. Substitute u value is equal to z plus 1 in the f of z. I will get this structure for the final answer. Thank you.